Okay, so today we're going to continue with lesson 7. Today we are going to solve rational inequalities. Again, we have 3 steps to follow. So the top is the screenshot from the textbook. The bottom part is my handwritten shortened explanation of what it says. So again, same thing that we did before. We are going to set our inequality equal to 0, make it an equation. We're going to find a common denominator this time. And then once we find a common denominator and simplify both our numerator and the denominator, we will set the numerator equal to 0 and solve for x. Set the denominator equal to 0 and solve for x. And then put those solutions on our number line and then plug in a test point. So here's my first rational inequality. Again, I need to change this into an equal sign. So I'm going to change it into 5 over x plus 4 equals 1. I'm going to move the 1 over because I need to set it equal to 0. I now need to find a common denominator. My common denominator is going to be the x plus 4. I'm going to multiply that to the top and the bottom. So now I get 5 over x plus 4 minus x plus 4 over x plus 4. Now that I found a common denominator, I also have to simplify my numerator now. So that it becomes 5 minus, and I'm going to distribute the subtraction sign. So 5 minus x minus 4 over x plus 4. All right, next one. Now I need to simplify that numerator. 5 minus 4 is 1 minus x over x plus 4 equals 0. Now that the numerator is simplified and the denominator, I take what's in my numerator, set it equal to 0. Set the denominator equal to 0. And now I solve for x in each one. So I'm going to add x here. I could have subtracted the 1 either way, but I get x equals 1 from the numerator. From the denominator, I'm going to subtract the 4, and I get x equals negative 4. The 2 answers I just got for x, these are going to break up my number line into the intervals. So just like before with the quadratics, I'm going to set up my number line, least to greatest. And again, I'm going to pick a test point. Doesn't matter what number you plug in. Again, I like 0, so I'm going to put my zeros located right here in the middle. My original problem again is 5 over x plus 4 greater than or equal to 1. I'm plugging in 0. So 0 plus 4, it's just going to become 5 over 4. Is 5 over 4 greater than or equal to 1? Yes. Yes, it is. So the middle where the 0 was located gets a check. The 2 sections on either side get the x. And then you write the answer the same way. There's only one slight difference. When your original problem has a greater than or equal to or less than or equal to, what do you remember about fractions and their denominators? What can't you have in the bottom? What would make the problem not work? 0. A 0. So which one of these numbers makes my denominator a 0? The negative 4 or the 1? Negative 4. The negative 4. So now instead of, technically I should be putting a bracket around the negative 4, but because it would make my question undefined, I'm going to change that bracket to a parentheses. However, the 1 would still work, so it gets a bracket. The only time you need to do this switch is when your original problem has a greater than or equal to or a less than or equal to. If it's just a plain less than or just plain greater than, it's automatically a parenthesis, so there's no changing. Okay, and the reason why we do this is -4 is our starting point, but it doesn't include -4. That's why we change it to a parenthesis. Yeah. Example 2. Now notice this original inequality symbol is just a less than. So once we get to the end, we don't have to worry about changing anything. But our steps are still the same. I'm going to turn it into an equal sign, and I'm going to set it equal to 0. So I'm going to move the 5 over to the left side. I get 2x minus 1 over 3x plus 4 minus 5 equals 0. I now need to find a common denominator. My common denominator is going to be 3x plus 4. The first fraction already has it, so let me just rewrite it. However, the second fraction is missing it, so I'm going to multiply it to the bottom and to the top. So this will become 5 times 3x plus 4. I need to distribute and simplify my numerator. I'm going to treat this as a -5 that I'm distributing. So the 2x minus 1 stays. Distribute the -5 and get -15 minus 20 all over the same common denominator. I now need to simplify my numerator. I can add my like terms. I'm going to add my x's. I get -13x. Add my constants. -1 minus 20 is -21. And then the same denominator still. Now that both the numerator and the denominator are simplified, I will set each equal to 0. So -13x minus 21 equals 0, and 3x plus 4 equals 0. Solve for x, so I'll add 21. -13x equals 21. Divide by -13. And x is equal to -21 over 13. Subtract 4. Divide by 3. And x is equal to -4/3. Again, these are the numbers that will go on my number line to break up the intervals. -infinity. The smaller one is the -21 over 13. Then the -4/3, going to positive infinity. Again, I need to find a test point. Again, I'll look for the 0. My 0 is located over here on this far side because both of my answers were negative. So again, my original problem is 2x minus 1 over 3x plus 4 less than 5. Again, if I plug in zeros here, this becomes a 0, so does this. So now I'm just left with -1/4. Is that less than 5? Yes, it is. This is a true statement. So I'm going to get an x in the middle, and then where I plugged in the 0 gets the check mark. I now write it in interval notation. So I'm going from -infinity up to the -21 over 13. I'm going to union that with -4/3 up to positive infinity. The original symbol was a less than, so parentheses straight through. Okay, example 3. Oh, look at this. It's already, all I got to do is change it to an equal sign. So x plus 1, x minus 4 equals 0. set the numerator equal to 0, set the denominator equal to 0. X plus 1 equals 0, x minus 4 equals 0. Everybody good? All right, subtract 1, x equals negative 1, add 4, x equals 4. Everybody with me? Those are the numbers that'll go on your number line. All right. Now I got to pick a test point. Again, let's look for 0. It's in the middle here. Go back to the beginning. It had x plus 1 over x minus 4. So if I plug zeros here, I get negative 1/4. Is that greater than 0? That's false. So that gets an x where the 0 was. Check, check. So now we'll write it as our compound inequality. Negative infinity to negative 1, unioned with 4 to infinity. Again, change it to an equal sign. So I'm going to move the 2 over. 6 over 5 minus 3x minus 2 equals 0. Common denominator. The common denominator is going to be the 5 minus 3x. So I need to multiply that to the top and the bottom here. So 2 times 5 minus 3x. I'm going to distribute. So 6 minus 10 plus 6x over 5 minus 3x. I need to simplify the numerator. 6 minus 10 is negative 4. Set the numerator equal to 0 and set the denominator equal to 0. 4 minus 6x equals 0. 5 minus 3x equals 0. Add 4. 6x equals 4. Divide by 6. 4 over 6 will simplify to 2/3. Subtract 5. Negative 3x equals negative 5. Divide by negative 3. And x equals positive 5/3. These will be the numbers that go on my number line. Negative infinity up to 2/3, then the 5/3, then positive infinity. Again, I'll pick a test point. My 0 is located over here since both of my answers were positive. So let me write the original. This one again, remember, if it starts out with a less than or equal to or a greater than or equal to, we're going to change the bracket on the denominator values. So let's go ahead and first plug it in. So when I plug in a 0 here, I end up with just 6 over 5 less than or equal to 2, which is true. It's 1 1/5. So the place where my 0 gets a check, then an X, then a check. So now I can write it in interval notation. So from negative infinity up to the 2/3. Now the 2/3 came from the numerator, so it keeps the bracket. I'm going to change the the bracket to a parentheses though around the 5/3 because that would make my problem undefined. So remember, this is where we got the 5/3 from when we set the denominator equal to 0. So that will be the number that you're going to change from the bracket to the parentheses. Just to give you an idea of, maybe just to clarify what this means by changing the bracket to a parentheses, let me add a page here. So for example, it would make it undefined. So anytime you're going to solve these, and if it's got a greater than or equal to, or a less than or equal to starting out, whatever number you got from setting the denominator equal to 0, change it to a parentheses. So it's the number you got when you set the denominator equal to 0.
Oh, it's always the denominator.
Yes, only the denominator number.
Only the denominator would be with the parentheses if it does have like equal to.
Yes. Back when you probably did this in elementary school, like if you had something like this, x is greater than 2. And when you used to graph it on your number line, 0, 1, 2, 3, when it was this symbol, remember it was the open circle. And this is where you started, and then it meant everything that was bigger than 2. And the reason why you started it on this number was as soon as you jumped off 2, let's say it was 2.1, then if you were to put 2.1 here for x, see how you get a true statement? But if you put 2 here, this isn't a true statement because there's not an or equal to. So you still need the starting point, and that's why you're going to start when we're writing our answers. Instead of using open circles, we're now using parentheses. Now, if it's a bracket, the bracket means it includes it. But if we include that answer when we were doing the denominator, all right, so again, set it equal to 0. So we're going to move the 5 over x. Negative 5 over 3x plus 2 minus 5 over x. Set it equal to 0. I need to find a common denominator. It's actually going to be both. It's going to be the x times the 3x plus 2. For the first fraction, you can see that it's missing the x. So I'm going to multiply the top and the bottom by x. And then the middle fraction is missing the 3x plus 2. So this becomes negative 5x. This one, I'm just going to put it here, and then I'm going to distribute it. So once I distribute the negative 5, this becomes negative 5x minus 15x minus 10. All over the x times 3x plus 2. Need to simplify. Negative 20x minus 10. Now, the denominator I'm not going to distribute because, again, remember, we would have needed to go back and factor it and then set it equal to 0. So I'm going to leave it I'm going to not distribute it. So again, set the numerator equal to 0. Add the 10. Negative 20x equals 10. Divide by negative 20. And x equals negative 1/2. Do the same thing to the denominator. However, remember for the denominator, we have this x that we set equal to 0 and the 3x plus 2. So this one is actually going to have the number line split up into 4 sections. So I have the x equals 1/2, negative 1/2, the 0, and the negative 2/3. So let me place that on my number line. Negative infinity. The first one, the smallest number here is the negative 2/3, then the negative 1/2, then the 0. Now, Remember, majority of the problems I've done in the past, I plugged in 0. However, this time I can't use 0 because 0 is one of my answers. So now I need to pick another number that's not one of those 3. So I'm going to plug in 1. So I'm going to choose 1, which is located over here. Let me get my original problem. I'm going to plug it in. Negative 5 over 3 times 1 plus 2. 3 plus 1 is 5, so negative 5 over 5. 5 divided by 1 is 5. Negative 5 divided by 5 is negative 1. Because this is a false statement, I'm going to put an X over that section. So I get an X here, and in between are the 2 check marks. So now, wherever there is a check mark, that is what's in my solution. So it's this section here. So from negative infinity up to the negative 2/3. Now remember, the 2/3, that negative 2/3 came from the denominator. So change it to a parentheses. I'm going to union that with the negative 1/2. The negative 1/2 came from the numerator. And then it stops at 0. And it gets a parentheses because it also came from the denominators. And that's your final answer there. All right, everybody good? Homework is here, 71 through 83 odd.